Okay, so today is higher degree polynomials. This is what this whole chapter is about. And I gave you some time. I'm hoping by now you've found it. Would you please turn your iPad my way so I can see that you have found the smartboard file for today. And at least I'll know who I'm still waiting for. It's under today's date. Yours is still on night shift, I think. You can get your colors back if you want them. All right, anyway, so the main three terms are leading coefficient. Leading sounds like front, right? Reminds me of one of my favorite sayings about the lead dog. You know, when mushers are taking their sled dogs out, they always have one that they put in the front. There's some dogs that are better at this, and then they put them in front. And if you're better at that, you put them in the middle. And if you're better at that, you put them in the back. And the lead dog, unless you're the lead dog, the view never changes, is the saying. So anyway, so we're going to look at the leading coefficient, and it's not just the thing that's in the front. Okay, if you think of these as a big long like sled dog chain, it's not just the lead dog. It's not just that one for sure. It depends. Okay, the leading coefficient is the number that's on that variable, and in this case it's a 1. But it's not just the one that happens to be in front. You can change the one that's in the front. Do you get, like, if it's a sled dog, that we could say this guy, I'm going to move him up to the front because he needs a turn of being in the front. You can do that. It can be in front, but it's still not the lead dog. The lead dog is the one with the biggest degree. It's that simple. If you have the biggest degree, you're the lead dog. All right, no matter where you are, even if you're in the middle of the equation, the one that has the biggest power is your lead dog. And the coefficient is the number on the front of that. All right, and the next thing is degree. It's really simple. If it's all multiplied out like this, the degree of this polynomial is 5. It's the biggest one. Whatever's the biggest, that's the degree. Okay, so even though there's 1, 2, 3, 4 terms here, sorry, 1, 2, 3, 4, the one that's most important is the one that has the biggest power, and it tells us what degree it is, and the number that's on that is called the lead coefficient, and it tells us something cool too. The last thing is called end behavior. The ends of these graphs, we're just going to keep it really simple. Do you get there's the left side of this graph and the right side of this blue graph? And we're just going to call it up or down. Okay, on the right side it's up, on the left side it's down. That's all there is to it. Okay, so now that's the main topics for today. And what is a polynomial? Go to that slide. A polynomial is basically a whole bunch of terms like this. And usually we say y equals to make them an equation, but we don't have to. By the way, if it doesn't have an equation, then technically it's called, starts with an E. Anybody know? It's not equation. Expression. It's an expression. It's a polynomial expression. All right, but if I put a y equals on the front of it, it's still basically a polynomial that's been turned into an equation. All right, so anyway, now what's the key? The key is all about the powers. Okay, and notice all it says about the polynomial is that it can have lots of different variables, and you can use add, subtract, multiplication, and constant positive whole number exponents. That's the key right there. If you had a negative exponent, it wouldn't be a polynomial. This guy's out. He's got a negative exponent there. So this whole thing is not a polynomial. Fails the test. It's also got a fraction exponent. Can't be a polynomial. All right? How about this guy? If you multiplied him all the way out, would he have any weird powers? No. So it's a polynomial. So it's all about the powers. This guy, do you get that there's a division involved? Did it ever say you could do division? Addition, subtraction, multiplication. It's got division. Because do you know what actually is happening when there's a division? It's actually a fraction power. Because like if I had 1 over x to the third, Do you get that's the same as x to the negative third? And remember how negative exponents aren't okay in these things? So this is not a polynomial because it's two things. It's got division in it, and this is the same as this. So, or you could say, well, this one doesn't have division, but it has a negative exponent. So also, it's out. So here's the question then. Polynomial or not? Is it a polynomial? Yes, and some people think you have to have poly means many, so therefore they think it has to have lots of terms to be a polynomial. No, it can just have a term and it's fine. That's still a polynomial. Now is it polynomial? No. Nope, can't have fraction powers. Or sorry, can't have negative powers. And you can't have fraction powers. That also would fail the polynomial test, not a polynomial. Okay, so there's the first thing is it a polynomial or not? The next thing is, what's the degree of it? It's super simple. Look at this. What's the biggest power you see? It's degree 6. Done. Look at this one. What's the biggest power you see? 4. It's degree 4. Okay, that's all there is to it. Please don't add up the powers. That's not what you do. Okay, you just pick the biggest one. All right, what's the degree of that one? 2. 2. That's all there is to it. Now, that term, notice I'm going to circle it in green each time here. The one that had the biggest one, that one I'm circling the negative in front of it. It's kind of important. And this one, those were the lead dogs. Okay, they were the lead terms. And they're important to know. Notice the lead dog wasn't in front this time. He may be the biggest, smartest, fastest dog, but he is not in front. So lead does not mean that it has to be in the front. The lead is the big one with the biggest power. Okay, and those tell us something, and I'm going to show you that on a different slide, but the point I'm trying to make is, find the biggest power to get the degree. It's that simple. But the one that has the biggest power, that's the most important term of them all. Okay? It's the one that's going to tell us a ton about this polynomial. All right, one more thing. The most common wrong answer is, it's degree 3. It's not degree 3. Why? Because it isn't multiplied out. If it was multiplied all the way out, then we'd pick the biggest power. It has to be multiplied all the way out. So, do I actually have to multiply this all the way out? No. There's an awesome shortcut. And it goes like this. Figure out what the biggest x to the whatever that there would be. Do you get that there would be something bigger than x to the third? If I multiplied this all the way out, this part would have an x to the third. This part would add another x to that, which would make x to the fourth. There's like a power of 1 right there. And then this negative 3 would go on it. The lead dog, the lead term, would be negative 3 x to the fourth. And then there'd be a whole bunch of no-name terms that really don't matter that much because they're not the lead dog. And so this tells us everything. So far, I've told you about degree. So what degree is this polynomial? Don't overthink it. Degree 4. Just the biggest one that there would be. Notice I did not pick the 3 because it wasn't multiplied all the way out yet. All right, so this one's degree 4, and its lead coefficient is the number in front. Whoever cell phone is on right now, just turn it off so we can't hear any notifications. I think I know who it is. Yours usually goes off 5 times an hour. It's not yours? Excellent. All right, anyway, this is the lead coefficient. What does the coefficient do? Well, it tells us simply one thing. The coefficient is the number that's on the lead term. That number, if it's negative, tells us that the right side of the graph, negative kind of sounds like down, doesn't it? And that's what it is. The right side of this graph. I don't even know exactly what this graph of this whole thing would look like, but I can tell you this much. It ends going down. The end of the graph would go down. And then how about the other end? This 4 right here being even. This one's very also intuitive. Either the graph has to be the same and they're both down, or it's got to be different and one ends down and one ends up. What does even feel like it should be? Does it feel like it should be the same as the other one? Or does even feel like it should be different than the other one? To me, once I tell you, I hope that it'll make sense. If it's even, then the end behaviors are the same. And if it's odd, then they're different. Doesn't odd and different kind of like go together? All right, so this is even, and therefore they both are going to go the same way. So this ends with both ends going down. There, I've just taught you everything in 13 minutes. But I totally get you don't know everything yet. I may have said everything, but you aren't like totally there yet. But this stuff isn't super hard. All right, within this, how many terms does it have? 3. It's got 3 terms. What's the lead dog? Negative 5x to the 4th. It tells us the degree of this polynomial. What degree is this polynomial right here? Degree 4. If I put the lead dog in front, which is usually where you put the lead dog, not always. I just rearranged it. I put my dogs in different places on the sled team. Okay. This one's my lead dog, and it tells me 2 things. That tells me the end of the story. That negative means it's going down on the right. The fact that this is an even one means that both ends are down. So if I were to sketch this, I would say, okay, I know from my studies that this even means that either they're both up or they're both down. And then which way is it? Well, this negative here tells me it's down on the right, and therefore it must be down on the left. Because it's even, they're going to go the same way. If it's odd, then it would have been different ways. I know you're thinking, well, so what does the rest of the graph look like? We'll tell you that later. For right now, all we care is that it does something in between, and then it ends that way. I can't teach you everything for the entire unit in one day. Well, I could, but you wouldn't remember any of it. So there is a way to tell what it's doing in between times too, but all we care about for today is how it ends and how it begins. Probably the most important parts of the book. Good beginning and a good ending. Yes? Good question. Today, all they're going to ask is, which way does it go, up or down? That's all I got to remember. But if I was going to sketch it, I would connect them. Let's say it ends up both going down, and you do anything you want in between. Just make a couple squiggles. Okay, we'll tell you exactly how it works in between later, but for right now, that's a typical polynomial. And you know that Desmos can graph this kind of thing, but you'll learn exactly how they look later. But now, if I give you this, I don't even care about that stuff. It's kind of cold, but all I care about is the lead dog. And it tells me everything. Would you make me a quick sketch of what you think this kind of looks like? All we really care about is the end behavior. The ends. Are they down or up? I hope you're judging this thing and saying, okay, it's positive. That means the right side, it's a positive story. It ends on a happy note. It goes up. You know, there are stories where the lead character like dies and like tragic story. Old Yeller, it's a classic example. The dog that protected them and was like their best friend and ends up getting rabies at the end. Oh, I hope I don't give away the ending, but anyway. So this one's positive, ends on a positive note. How about this? Since this is odd, remember odd is like different, and therefore down over here. And then you can connect them any way you want to. But I'm going to like give you a little hint of the future, a little premonition of the future. Did you know that the Y-intercept is where x equals 0? If so, you can quickly ascertain that that is the y-intercept. Do you get that whatever this thing is doing between here and here, it has to hit at 7? Makes sense? All right. Now, we aren't even going to judge you on that today, but it isn't hard to do. Just look at the last number. So apparently the stuff at the beginning and the stuff at the end are the most important parts, and stuff in the middle doesn't matter that much. And that's pretty much true. All right. Why? Because that's the y-intercept. Why? Because x equals 0 is where the y-intercept is. That's a 0. That's a 0. These guys get canceled. Y equals 7 is apparently important. Okay. So let's get to this page right here. Which one is the lead dog? This one is. Would you just circle the lead dog in each one? Circle the lead dog. Technically, we're doing is circling the lead term. And then the number that's in the front of that, that's the leading coefficient. Okay, lead dog, lead dog, lead dog, lead dog. And this one doesn't have a lead dog, but you remember how I made it? I made the lead dog in this one by going x to the third, x to the 1 makes x to the 4th, a -3, -3, x to the 4th is the lead dog on that one. See how I did that? This was x to the third, this was x to the 1, that makes a total of x to the 4, and you just, whatever the lead coefficient is, you slap it on there. Okay, now why does that help me? Because it tells me the lead coefficient. This one's got a 1, this one's got a 5, this one's got a -1, notice it was a negative on there, this one's got a -3. Oh, and this one's got a -5. Do you get some of them have a story that has a sad ending? It was down on the right-hand side. Which ones go down on the right-hand side? Nope. That one, and this one. Why? Because they all have a negative in front, so they go down on the right. Then, if they're even, they'll be the same on the other end. If they're odd, they'll be different on the other end. All right. This is that whole build the lead coefficient thing. Number 1. The answer might be like 5x to the 7th. Figure out what that lead term is. What's the lead dog? Once this got all multiplied out, what would be the lead dog? And it's not 5x to the 7th. Figure out what it is. Compare it with the kid next to you while I get attendance done. Okay. Hopefully, you said that this should be bigger than x to the third, because that's just that part. And then this is next to the second. And if you put them together, this is important, it's x to the 5th, not x to the 6th. Okay? Because these are getting multiplied, and x squared times x to the third makes x to the 5th. If you wanted it to go like this, that'd be totally different. That was not what we had. What we had was this. So it was x to the 5th, and then this 2 in front was important. So did you say 2x to the 5th? Raise your hand if you had that right. Good. Then, more importantly, what does it tell us? It's positive. So how does the story end? Up. Happy. Yes. Okay. It's got an odd power. What does that tell me about the front? Down. So this one's down on the left and up on the right. And in the meantime, we don't even know what happens. If you wanted to be extra smart, you could set x equal to 0 and figure out what the y-intercept was. I'm not going to require you to do that. I'm just leading you because that's where we're eventually going to go. So you can connect this any way you want to. There. Okay. This guy. Now that you did the last one, this should go quicker. What's the lead coefficient on that one? The lead term, and then the number on the lead term is the lead coefficient. Negative. I could put a 1 if I wanted to. X to the 1, 2, 3, 4, 5, 6, negative x to the 6th. Raise your hand if you had the same thing. Didn't notice that x in the front? Think of it this as, it doesn't have a parenthesis, but it's still an x in a parenthesis. You can put parentheses on it. All right, so then, how does the story end? Down on the right. How about this? What does that tell me? Even means the same, so it's the same on the other end. Down, down. And if I really wanted to be extra smart, I could put in a 0 here and there. This one's kind of cool because it seems like it'd be really complicated, but it's 0 times everything, which makes what? 0. It has to go through 0 as its y-intercept. Again, not testing on that yet, but we'll teach you about the in-between parts of the function later. As long as you knew it ended and began with down, we're good. Okay, so the blank and the blank determine the end behavior. The degree, whether it's odd or even, and the leading coefficient, if it's positive or negative, determine the end behavior. All right, so if you looked at this guy, would you agree it's up and up? Then tell me, could this possibly be the lead term? No, what's wrong with it? This one is not going down on the right. Somebody's saying that, but it's not right. The one I just wrote wouldn't be going down on the right. It would be positive. See, there's no negative here. That would be going up on the right. So it isn't the 5 that makes this wrong. It's the 3. So it shouldn't be a 3. It should be, what could possibly be right? A 4 or a 6. Any even number would have been okay. All right, moving on. Tell me, just tell me, up, down, down, up. What's the first one? Up and up. How about this one? Down and down. Okay, on to this one. Up, down. Down, up. Don't overthink these. They're just ups and downs. Don't say it as increasing and decreasing. They'll get you all screwed up. Don't do that. It's just up, down. Okay. So this guy, the one that you've known forever as x squared, the technical reason why it was going up on the right was because this was positive in front. Do you get if we made it negative in front, the whole thing would flip over and the right side would be going down? All right. How about this guy? It tells me as soon as I see that negative, I know the story has a sad ending. It goes down on the right. And the fact that this is even means they must both be the same. Down on the right, and they're both the same. See? All right, moving down to this in the middle here. X to the third. You know this is what it looks like. I hope you have that memorized by now. The snake. Okay. Why is it going up on the right? Because it's positive in front. Why is one end down and the other end's up? Because it's... Why is one end down and one end's up? Because it's odd. Is one end down and one end up on this one? Yeah, because it's odd. Why is it going down on the right side? Because the negative. Last set I'm going to go through anyway. This is important to know. The odd and even ones all kind of look alike. If you have an even one, doesn't that kind of look like x squared? X to the fourth looks just like x squared. X to the sixth looks just like x squared. They just get tighter and tighter. They make their turn really sharp. If it's x to the sixth or x to the eighth or x to the 10th. All the even ones look like that, and take a wild guess what all the odd ones look like. They all look like x to the third. X to the fifth is just a little tighter turn than x to the third. X to the seventh just look like this again, except a little tighter turn, sharper. So, what would negative x to the ninth have to kind of look like? Think it through. Make me a little sketch. Remember that all the odd ones kind of look alike? It's true. You guys only know about orange carrots, probably. Do you know the original carrots were actually purple?
I did not. I think I looked
carrot growers in, where was it, like Norway or Denmark or wherever they were, like the guys who invented the carrots, they actually just hybridized them. They actually just like got different varieties. You know, like you can breed dogs to look different. You know, you get the little long, skinny wiener dogs, and you got your great big like wolfhound kind of dogs. They're bred that way. Carrots were that same way. They weren't orange for quite a few years. They actually took white ones, and I think it was yellow ones, and then they put them together to make the classic orange carrots that we have today. And by the way, they also bred them for taste because, of course, if you have a cool looking carrot but it tastes terrible, nobody's going to buy it anyway, right? So the orange ones that we eat today weren't around a long time ago. Didn't exist. Carrots haven't always looked like that. They bred them to taste good and be a cool color. It used to be purple. At least that was one of the main varieties. All right. So we have all of these kind of look alike. All carrots kind of look alike, except their colors are different, right? Well, all the odd ones kind of look like this, except sometimes they're flipped. Is this the right answer for this? No, because this negative means that it's down on the right. So I got to make something that kind of looks like that, but is down on the right. So then I go like this and like that. There we go. All right. I think you're going to have it if you can answer this question. I'd like you to be careful about the lead dog here and make a sketch of what this could possibly look like. Even if you don't know exactly, you should know how it ends. You should know both ends, in fact. And if you're extra smart, you'll include something else besides just the ends. I'll pause for a second and give this a try. Nice at Destiny say I should talk to row 3, person 3. That's you. Tell me something you know. Down where? On the right, it goes down. Tell me what part told you that. All right. Where is he messing up? Somebody extra smart. I would have thought the same thing, but you got fooled. Oh, you caught it. What did you catch? The leading term. It's that guy. That's the leading term. So it's not going down on the right. It seemed like it was. Instead, it's going up on the right because it's positive. Okay, now what? Tell me more. Down on the left because it's an odd one. All right. So they have to be going opposite directions. And were you extra smart? Maybe not. Okay. It's okay. What do you think?
The Y-Intercept is -5.
Yes. There it is.
Oh, yeah.
I don't care what it does other than hitting here and being up on this end and down on that end. And you don't have to be good. You don't have to do that part even today, but I'm getting you ready for the future. All right, cool. You are totally ready to take the Schoology quiz, and some of you are going to finish it in class and walk out of here with no homework. So get that puppy done. The way I've got them set right now is average score. That'll prevent people from going through getting really crappy scores, seeing what all the answers are, and then just putting them all back in and getting them perfect. Okay, that's not really fair. Try it the first time. If you get something wrong, you get enough things wrong that you think you should redo it, go ahead and redo it, and you'll get the average of the two. It will bring your score up because you'll know all the answers, right? So if you get a 7 the first time, it's probably okay. But if it was out of 14, I guess probably time to redo it. All right, that's all I got for you for the video for today.